Good morning and good afternoon, everyone. I'm Kris from the Warning Decision Training Division. Along with me is Jill Hardy, also from WDTD. I'd like to welcome all of you to our second installment of our revival of the Storm of the Month series. Today's presentation comes to you from the National Weather Service Forecast Office in Huntsville, and our presenters will be Ashley Ravenscraft and Kris White.
Okay, hi everyone. Thanks very much for attending our talk. Good afternoon or good morning, wherever you may be. This is Kris White. I'm just going to start out and speak to a few slides, and then Ashley's going to take over and talk to a couple specific cases. So to go ahead and get started, just a little bit of background first about the use of total lightning data here at the National Weather Service office in Huntsville. We have had a long history with the use of total lightning data. Originally, these were provided by the North Alabama Lightning Mapping Array. I'll just refer to this hereafter as the NALMA. The transition of those data started all the way back in spring of 2003. And over here on the upper right, I actually have an image from those old days, right after we first started getting the data into AWIPS here. Just like the GLM now, the NALMA provided total lightning. It was one of the first ground networks that we had data access that provided both CG and intercloud lightning. And of course, it's different than the GLM because those data are produced via VHF radio sources. Originally, when we got the NALMA data into our office, they were in the form of source density, which is something a little bit different than flash extend density. I'm not going to get into that. It's not the scope of this talk, but nevertheless, there was a little bit of a transition between when we had source density data to then getting flash extend density. And part of that was just the process of packaging up those data and delivering it. But the important thing is that both of those, and especially the flash extend density, are related directly to storm updraft strength. So over time, we did develop, we did incorporate those types of data into our warning methodologies. And also, of course, having the intercloud component is important because usually the intercloud flash precedes the cloud-to-ground one by about 5 to maybe up to 10 minutes per the research. Fairly similar to the current GLM data, we did get those in every 2 minutes in our AWIPS, so we had 2-minute resolution. And of course, they served as a proxy thus for the Geostationary Lightning Mapper. And so now, well, we're in the GLM era. We served as a preliminary test and evaluation office beginning back in the spring of 2018. So we've had now about 2 years of experience familiarizing ourselves with the GLM and some of the various variables that have been passed through into AWIPS that have been produced from GLM. Initially, we use the data typically for situational awareness purposes, for the common things like airport weather warnings, whether or not a cell was just electrically active. The use for severe weather warnings was a little bit slower to evolve, simply because we had to kind of readjust or recalibrate what was considered to be significant flash extent density values or jumps as opposed to what we were familiar with when we were in the NALMA era. But over time, we have began to kind of recalibrate that and beginning to see what is important. But nevertheless, the main thing is that the lightning jump is related to storm updraft strength or the sudden increase in storm updraft strength. So that's one of the main things. Okay, so our top priority when issuing warnings is, well, the protection of life and property, as we all know. So how can we do this? Well, we prioritize detection and lead time. And that's something that the GLM can help provide is maybe a little bit of lead time. That's been our experience. And by becoming skilled in these methods and tools that increase our lead time in detection of severe storms, for example, the 3 ingredients method, which is very important for QLCS, storm warning methodology, GLM, which of course we're going to talk about. Actually, we're going to talk about both of those, both utilizing the 3 ingredients method and the GLM data in concert with each other. And there's other tools out there like Prob Severe or some of the RGBs can be helpful. And also practice with the WES. So some of the learned benefits of GLM during especially QLCS events so far, and we have an abundance of those here in the Tennessee Valley. The 1-minute updates can show rapid intensifying updrafts, and these can occur between some of the, some of the typical volume scans or same elevation scans on the radar. It serves as a secondary layer of evidence. So we might start out with other sorts of evidence that a storm is producing severe weather about to based on other radar data or other satellite data. But then a lightning jump seen by the GLM can just add a secondary layer of confidence that a warning might need to be issued. And it also might help you determine whether or not you need to continue a warning in some situations. And even minor upticks or increases in lightning can be significant depending on your weather environment. And this is especially So for cool season convective events that we have often here in the Tennessee Valley as well. So within the challenges that we still face, well, is determining the threshold to warn versus not warn. I mean, I think we all grapple with that, especially in QLCS events, because sometimes, the data that we see, it's not really lying one way or the other as to whether or not you should warn or warn. So sometimes the GLM can help tip the scales in favor of warning versus not warning. And of course, we, as many areas do, you suffer from poor radar coverage in some parts of your CWA. We do pretty well here, and as you can see, some areas have a little bit less, but GLM might be something that you might want to consider. Now, with that said, I'll pass it off to Ashley.
All right, good morning / afternoon, everyone. So the first case that we're going to go over happened December 16th last year. So discussing the challenges first, with this case, as far as challenges, there weren't too many, just a couple from a messaging standpoint. The event was set to occur near or after sunset, so it was occurring after dark, as that is often the case around here, especially with our QLCS events. And then there were some concerns about inadequate moisture and instability ahead of the line of storms. We figured that our northwest counties were probably going to be a hot spot if we were going to have any issues. And I have highlighted that area, put a circle around our northwest counties. That's where we're going to focus for this case review. So it was a conditional but a potential high impact event. How GLM played a role in our warning decisions with this case. For once, I was able to get in a couple hours before we got busy here. I immediately started looking at things upstream to our west, and I was able to notice strong lightning jumps looking at GLM 1-minute data ahead correlated with these surges in the QLCS that had tornado warnings on them, and kind of just set my thresholds accordingly. So we had heard that there were several tornadoes that were confirmed with these storms. So I said, okay, if this is what it looks like upstream, then I can kind of expect these trends to continue given the environment and everything. I'll kind of dive in. I'm going to tab through these frames minute by minute. So just diving in right now, the first thing, we already had a severe thunderstorm warning out. We saw the evidence that the environment was very supportive of at least severe wind gusts into northwest Alabama. So we went ahead and put a severe thunderstorm warning out based on that, and based off, we were looking at GLM, and we could see that there was some pretty high lightning activity with that. So I'll go ahead and kind of step through. Also notice that with the surge in the SRM that's in the upper right corner is becoming line normal to the 0 to 3 kilometer bulks here, which if you look at the 3 ingredients method, that is one of the 3 ingredients. So as we step through, you can see the lightning activity is still, it's very persistent. And there might be some temporary pulses kind of up and down in activity. The first time we really started to notice a strong lightning jump was now at this time. And then, so based off of this, we went ahead and issued our first tornado warning for our area. Based off the 3 ingredients method, if you look at, where the inflection point is and how that relates to the shear, plus with the lightning jump, we said, okay, the environment's very favorable. What we see on radar is very favorable, and we can kind of infer based on the lightning activity going up pretty quickly. Our updraft is growing. Let's try to get ahead of this. If we know that tornadoes are kind of, that the downdraft plays a big part in tornadogenesis, let's try to catch it on the way up. So we went ahead and threw out the first tornado warning, and then we kind of saw this persistent high lightning activity, and then we kind of saw our first maximum there, which precludes, and then a secondary maximum, which was when we were really starting to get concerned, and we were, over the phone with our emergency manager saying, hey, we're really starting to get concerned about this area, and that kind of, precluded our first EF1 tornado, which is marked in the upper right panel. We went ahead and issued, a warning to the north just to kind of give us a little more buffer space there, since there were several, at least broad rotation signatures that we could see on radar. And we had a third maximum, so we had every indication to say that we were at least going to have one tornado with these storms based off what we could see off radar. And then the lightning activity stayed, pretty active. We again had another tornado that was in eastern Colbert County, kind of the middle county that you can see there. That was a strong tornado. And then saw another lightning jump ahead. This begins the lightning jump ahead of what would unfortunately become a killer tornado right here in northern Lawrence County, that we actually made the decision to upgrade the warning to a considerable tag. For one, we saw the lightning jump out ahead of that, and then what we were seeing on radar, it gave us enough confidence to go ahead and pull the considerable tag with that. We were able to let the emergency managers know, hey, we're really concerned for this particular community. And I know that it definitely increased my confidence during this event. So I will continue to tab forward here. So what happened was that, our stronger tornadoes did happen in the northwest portion of our county warning area. We did have 2 EF2 tornadoes. Those were both correlated with pretty strong lightning jumps that we're seeing in GLM, and were correlated with the surge in the line there. To kind of wrap up the first case, what was GLM's role in our warning decision? Well, for one, it gave us confidence to continue tornado warnings, to issue our first tornado warnings into the western portion of our county warning area, where the surge and the high lightning activity was noted. And it was, again, an added layer of confidence when the decision to include the considerable tag was made ahead of the Town Creek tornado. That was the first time that I've ever had to make that decision, and luckily, I didn't have to make it alone. I got feedback, but I will say, even though it wasn't the strongest lightning jump that we saw from that event, just the fact that there was one at all, and correlating that with what we saw on radar, I said, I feel pretty confident that this is warranted. I mean, it helped improve our lead time tremendously. I think last time I went back and looked, our average lead time on these warnings was around 30 minutes, which was, about as good as we could ask for in an event like that, especially at night where, people's first instinct might be to go out and look at things, unfortunately. We'll go ahead and dive into the second event, which happened January 11th of this year. A little bit more in the way of challenges with this event. For one, our instability was a bit more limited than what we saw on December 16th. We were fortunate enough to have some students out from the University of Alabama in Huntsville launching soundings out ahead of this. And I think the highest amount of instability that we saw was recorded in Haleyville, which is kind of the south of where our county warning area is. Was about 500 joules per kilogram of surface-based instability. This led to a lack of lightning activity, especially west of Interstate I-65, which kind of cuts our county warning area in half from west to east. Also, our high top radar, which is located in northeast Alabama, went down, unfortunately, just before the event started. So if you look at our radar coverage map, basically a good chunk of our county warning area, especially areas to the east, we were without, decent radar coverage for there. So the closest radars were Columbus, which is in northeast Mississippi, Birmingham to our south, and Nashville just to our north. So because of that, we didn't have a very good feel for what was happening in the lower elevations. We had Armor, which is a radar that is located at the Huntsville airport, but there's a delay when we get the scans in. So that doesn't come in until the entire volume scan is complete. So before we see the lower elevation scans, it may be 5 minutes late. So it's good for going back and reviewing, but in real time, it's not as useful. There was also a lack of reports with it, so it's kind of hard to determine what, if any, damage was being done. GLM's role in our warning decisions on this day was that we first noticed a significant lightning jump with the Pickens County storm in Birmingham's area. And this was related to, unfortunately, another deadly EF2 tornado. So we knew that the better instability axis was going to be to our south in Birmingham's area. So we kind of adjusted our thresholds accordingly. So we said, okay, we may not see a lightning jump quite to this magnitude, but it may be one of those cases where if we start to see any kind of increase at all, that may be significant for us. So we did. We started to see lightning activity increase over Coleman County, which is our southernmost county, and that corresponded with a surge in the line of storms. So we issued the first tornado warning primarily based off of the 3 ingredients method. There wasn't a lot of lightning at the time, but we could see that surge. It was becoming more line normal to this year, which I'll show here in a minute. But then we continued to monitor any increases with GLM. GLM did play a role with our second and third warnings that were issued downstream, and there was a clear lightning jump that precluded an EF2 tornado that actually hit a school here. So to kind of dive into this case, Coleman County is the one where the severe thunderstorm warning is currently located. It's kind of dead center in the in the map there. So you can kind of see where in the upper right corner I've kind of drawn out where the inflection point is, where it's starting. You're starting to get that surge in the line based off what we could see. And this is using the Columbus radar in eastern Mississippi. So that was what our first tornado warning was based off of, was that surge. And then we started to notice a little bit of a lightning jump just south of our county warning area related to a storm in Birmingham's area. And then we kind of started, as we step forward here, we start to notice lightning activity start to pick up in Coleman County. I've highlighted that on the screen here. So that immediately catches our attention. You can also notice, too, on the satellite that your cloud tops are cooling. So we're saying, okay, maybe we're starting to tap into a little bit better instability here. Our confidence is increasing that if there's going to be a tornado, it's probably going to occur, within this region and here pretty soon. So based off of these things, we went ahead and started to see kind of pulses in lightning activity, still started to see the surge, started to see at least broad rotation aloft. We went ahead and issued a warning downstream at this time, and then we still started to notice these trends were kind of continuing. You start to see another uptick in lightning activity that's kind of pulsing in and out, but still kind of persistent. And so just stepping through, then we start to notice that it starts to pick up even more once it heads into Marshall County, which borders Coleman County to the northeast. So this is when we start to talk to our emergency managers and say, hey, based off of what we're seeing, we're starting to get concerned for these areas. We'll be in touch, but our concerns are increasing that a tornado may be occurring or is soon to occur. So we saw kind of our first maximum. This was the highest activity that we had seen for the day. So at this time, we briefed emergency managers that a tornado is likely forming, and we began drawing up a downstream warning for issuing a tornado warning beyond what we had currently. And then we saw a secondary maximum. It was at this time that we briefed emergency managers that a tornado is likely occurring near a small community near called Union Grove. And we went ahead and issued that downstream tornado warning. And so you can see the lightning activity is still kind of elevated, and that was the highest that we saw that day. So we were pretty confident, just kind of based off what we could see on radar, which was just broad rotation aloft. We were pretty confident that something was going to happen. That was where it was going to be. So what happened that day? We had a short brief weak tornado in northeast Coleman County. This is Coleman County right here in the bottom left portion of the image. And then we had an EF1 tornado. That was actually the longest track one that we had that day that crossed the northeast Coleman County border into southwest Marshall County. And then the strongest tornado that we had today, it was very, very brief based off what we found in our damage survey. But it was rather intense when it did occur, and that coincided with the strongest jump that we saw in lightning, which I thought was interesting. But that occurred right there in Union Grove, which was where we were concerned about. So this is just a picture of what happened. This is the Brindley Mountain Primary School. So again, it was very brief. This was definitely where most of the damage was. I don't even think it was on the ground for, maybe half a mile. But luckily this happened on a Saturday, I believe, so there weren't any kids in the school at the time. Obviously it could have ended very differently had that been the case. It was a nice success story to be able to talk about, how GLM really aided in our confidence with that, especially given that our radar coverage, what we were able to see on radar was a bit limited. So just to kind of recap everything, a few lessons learned and best practices that we have learned here in our office locally. We strongly believe that GLM is an essential tool and should be utilized during every convective warning situation. I know now, for me personally, I will not sit through and work radar without having it up all the time on one screen. And also an important note, in order to maximize detection, forecasters do need to be well practiced on the 3 ingredients method, especially dealing with QLCS cases, because GLM is a nice tool, but if you aren't well versed with the 3 ingredients method, it's not going to be as useful. So that is very, very crucial to warning operations. GLM, we've seen it's aided in detection and increased lead time with warnings, especially with that first case that I reviewed, as well as messaging during an event as well. So it's an easy way to visualize when updrafts are intensifying, especially when they're rapidly intensifying. Also, just practice this. Practice using the 3 ingredients method in conjunction with GLM during weather event simulator cases, or on cases where you might be on a quieter evening shift and there might be something going on in another part of the country. Just pull up radar, pull up GLM, and just kind of dive into it for yourself. And I really do think that this will help forecasters become more comfortable integrating this into their warning process. So for additional information, there is a nice article on the NASA Sport blog about the use of GLM data during the early March Tennessee tornadoes, the EF4 that impacted the Cookeville and Nashville areas. So with that is all I have. So thank you guys again for letting us present, and we hope that you got something out of this.
I'll go ahead and say that that's the end of this week's Storm of the Month, so I want to thank our speakers again, Ashley and Kris at Huntsville, for giving this great presentation. Thank you for the speakers, thank you for your participation, and we look forward to seeing you guys next time.